Now we're gonna go to 3.8, Newton method. Alright, we're gonna use Newton method to approximately zero of the function. So basically we want to find the x-intercept. This example I know is pretty simple. You can use calculator, but a lot of time you cannot, or you don't have calculator. So I have a function f of x is equal to x to the cube minus 3. I want to figure out what x that make this whole function equal to 0. So at random, I start with 1.4. I substitute it in. I have negative 0.256. I substitute 1.5 in. I get 0.375, which means 0 is in between these two numbers. So my x is going to be between 1.4 or 1.5. Alright, so to use Newton method, you're going to have to use this formula. Look at the formula, f of x of n, we have that already. This is the equation. And then you need to take the first derivative. First derivative of x to the cube minus 3 is just 3x squared. Alright, so for this example, I'm just going to round my number to 4 digits. So I create a table here. Alright, my first n is 1, and my number start from 1.4. Again, I need 4 digits. I create a column, so we're just going to start from the first column, the first row from left to right. Alright, f of x of n, I'm just substitute n, x of n for 1.4 raised to the third power minus 3, and this is the number that I get. Now when you take derivative of a function, you get 3x squared. Again, substitute 1.4 for x. I end up with 5.8800. When I do the f of x of n divided by derivative of it, so I just take this number that I just calculate over this number, and I get negative 0.0435. Next step, I put in the final formula here, which is x of n minus this whole fraction, which I just did calculate it here, and this is the number I have. And then I'm gonna continue for n equal to 2, use that number. Repeat the process again. Alright, I'm repeat the process again. And then the last number here, I'm gonna check. Plug it in the function, which is x to the cube minus 3. So f of 1 minus 1.4423 to the cube minus 3. I end up to something very close to 0. If you want to check using calculator, which is much easier, is cube root of 3 is 1.44225. Alright, let's look at the application. Hi everyone, let's go to the application of 3.8, which we're going to apply Newton method to find relative mass. Alright, let's look at this example. The concentration C of a chemical in the bloodstream T hours after inject into muscle tissue is given by this function. And they want to find when is the concentration the greatest, which means relative max. First thing I'm gonna do, I'm gonna take the derivative of this function. I'm gonna use the quotient rule. Again, the quotient rule is denominator times derivative of numerator minus numerator times derivative of denominator divided by denominator squared. After that, I distribute, alright, and then distribute minus in, simplify, and I got this whole rational function. It's not quite as easy as the first example to find the zero of this function. So I want this t to make this whole function equal to 0. Now look at the function. We don't want denominator to be 0 because otherwise undefined, and we want to make sure that numerator is equal to 0. So I'm going to use the Newton method. I'm just going to work with the numerator at this point. Alright, so I multiply everything by -1 just to make it easy for myself. So I have this function, and I want to approximate what number would make this function equal to 0. I substitute 4 for t, I get negative 3.57. I substitute 5 for f of t, I get 5.75. So my t is between 4 and 5. Alright? But instead of start from 4, because it's from negative 354 to 575, I'm going to start from 4.5. You can start anywhere you like, but I think that's probably the good place to start. Again, I'm going to start from this function over here. Alright, use Newton method approximation to find the zero of a function. I take the first derivative. Remember, this and the c prime is not the same thing. Alright, it's two different things. This one, I use this just to find the zero. Take derivative of this. I have 12t to the cube plus 6t squared minus 300. My n1 will be 4.5. Follow the procedure from the previous section example. I do that twice, and I have 4.4863. I substitute this number in f of t. 3, all of this in f of t. And it's turned out to be negative 0.02. It's not exactly 0.000, but it's good enough for me. Alright, so this is my critical number here. Again, I'm going to use the first derivative test because I don't want to take second derivative of this. So you took a number is in interval of negative infinity up to 4.4863. I pick 4 and plug it in this function over here. Alright, this function over here, and I get positive. I don't really care what number, I just want to make sure it's positive. Alright, same thing on this other side. I pick 5 and plug it in here. I don't really care what number, but I know it's negative. So I know that the function is increasing and then decreasing. So my relative max is 4.4863. So the greatest concentration is when time is 4.4863 hours. Alright, see you next section. Bye.